Welcome to the last video on the playlist. In this video, I'm going to walk you through using density and volume information for your calculation. Once you have the density of the powder and the volume, the size of the capsule shell, you can use the information along with the equation density is equal to mass over volume to interplay between your data and solve your calculation. So the fill capacity of a hard shell capsule is dependent on the size and the type of the formulation. The fill weight of the powder can be calculated using the density value and the volume of the capsule shell, and that's what we are going to focus on. So once you have the density of the powder, you can make mass the subject of the formula to find out the fill capacity for the powder that you're dealing with, and the volume of the shell is always given. Let's look at this. This is a refresher from video number 1. Capsule Connection has on their website the different capsule data size available for you. And I've extracted here that there's a powder at 0.6 gram per mil density. The volume of the 000 shell is 1.37 mil. And so when you make the capacity the subject of the formula, you'll find out that 822 milligram, which is what they have right here. And that's how they get all these figures right here in this table. The density of the powder, the volume of the shell, which is right here, and you can easily solve for the fill capacity and solve your calculation based on the fill capacity. Now, important things. The density of the powders must be given. 0.784 gram per mil, starch is 0.809 gram per mil. The weight of the shell is important in the end, and the volume is equally important. So the drug occupies a known volume, that's the fill capacity. The diluent occupies a known volume, that's the fill capacity. The shell comes as a known volume, that's its own capacity. So once you know the density equation, you can easily flex, make anything the subject, and do your solutions. Now let's look at this. You can solve this question using the fill capacity approach and the displacement method. All you need to do is to make the mass, the fill capacity, the subject of the formula, using the density information and the volume of the shell, and solved for the fill capacity. Let's do this on this slide. Once you solve for the fill capacity, we now know that 235 milligrams roughly of the valsartan fill a size 3 shell. 243 milligrams roughly of the starch fill a size 3 shell. And so all you need to now do is to find out the starch represented by the total active ingredient, which we had proven to be 40 milligrams times the 5 shell, right? 3 plus 40% extra, we're making 5 capsules, and you get 200 milligram, and you'll proceed with the calculation based on the displacement method. But what if you don't want to go the displacement method route? You love to work with the volume. Very easy. Using the total API, 200 milligram, the volume that the ingredient will occupy, you just make the volume the subject of the equation. So volume is equal to mass over density. 0.2 gram, which is the same as 200 milligrams, divided by the density of the active ingredient, which is the valsartan, to give you 0.255 mil. So 200 milligram of drug to make 5 capsules will occupy 0.255 milliliters of space. So the volume of each shell is 0.3 mil. The total volume for 5 capsules is 1.5 milliliters. So what do you think we do? The total volume for the 5 capsule minus the total volume the ingredient for the 5 capsule will occupy leaves a void, a deficit of 1.245 milliliter. What does that mean? To find out the mass, the quantity of diluent to fill this void, this is now a void, we say the density of the starch, 0.809 gram per mil, times 1.245 milliliters, and that gives us 1007 milligram. Here, this is how it goes. The valsartan is 200 milligram, Starch is 1007 milligram. Add both to the total powder mass. The powder per capsule is 241 milligrams, 0.4. And when you add the shell weight to that, voila, our capsule will be 287 milligrams. So feel free to work from the volume perspective or solve for the fill capacity information and work it using the displacement method. Either perspective can work. And that brings us to the end of the last recording in under 6 minutes. I hope this was beneficial to you. Thank you. Your take-home assignment is there. You do have the PowerPoint at your disposal. Please go through and practice. Get past papers and practice as much as you can. And that's it for our capsule delivery. Thank you so much, students. All the best.